sit down for a moment and let the noise fall away. We're about to move beyond Earth, beyond the solar system, toward the far edges of the universe. Not because something has ended, but because something vast is about to begin. Right now, everything you know unfolds in days and in years, in small, manageable pieces of time that feel almost predictable, as if the future were just an extension of the present. But beyond that narrow frame, time stretches into distances so large that intuition begins to fail and the mind loses its sense of scale. Out there, the same quiet laws that guide a falling stone are shaping the movement of stars, assembling galaxies and slowly transforming everything that exists. A single human life is impossible to trace with certainty, full of interruptions and choices. But the universe does not hesitate. It follows rules that do not bend. And if you follow those rules far enough, something begins to emerge, something already inscribed in the structure of reality itself waiting to unfold. So instead of looking forward the way we usually do, moment by moment, we're going to move differently. We're going to let time slip, faster and faster. Centuries begin to collapse into seconds, then millions of years pass like a breath, then billions, until everything familiar dissolves and only the deep structure of the universe remains visible. The sky appears unchanged and the earth keeps turning as if nothing could ever disturb its rhythm. Far above, something ancient returns. A dim streak cuts across the inner solar system, following a path traced long before any memory. The comet passes through and slips back into the dark, repeating a journey that does not belong to human time. Halley's Comet, known since antiquity and returning roughly every 76 years, crossing human history again and again long before its path was understood. Years stretch into centuries and centuries dissolve into thousands until the sky itself begins to shift. The stars no longer hold their places. Familiar patterns loosen and disappear as each point of light drifts alone through the galaxy, slowly rewriting the map of the night. Somewhere in that distant unfolding, a massive star reaches its end. For a brief moment, the night is broken by a second light. The explosion burns even against the day before fading, leaving the sky quiet again as if nothing had happened. Through all of this, the Earth continues to change. Across tens of millions of years, its rotation begins to ease, drawn gently by the moon. The difference is invisible in a single lifetime, yet it builds without interruption, stretching the length of a day little by little. As tens of thousands, then millions of years slip past, the marks of humanity begin to soften, edges blur and surfaces yield. What once felt permanent gives way to wind and rain until even the idea of durability loses its meaning. On the moon, over millions of years, the first footprints fade beneath dust and radiation, until no trace remains that they were ever there. Far from Earth, the objects we sent into space continue alone. Over hundreds of thousands, then millions of years, one of them drifts beyond the sun's reach, crossing the distance between stars and passing near another system long after its origin has been erased from memory. Time keeps accelerating, and after millions of years, the quiet balance of the solar system begins to shift. A distant star passes close enough to disturb its outer edges. Reservoirs of ice and stone are nudged from their stillness, and a slow wave of comets begins falling inward toward the sun. Over tens of millions of years, the surface of Earth refuses to stay fixed. Continents move with a patience that cannot be perceived, yet never stops. Oceans open where land once stood, while others close without a sound. In what was once Africa, a fracture deepens and widens until water fills the divide and a new ocean is born. separating a continent that once held together. Hundreds of millions of years pass and the process reverses. Land gathers again and the continents merge into a single mass. Mountains rise and vanish in cycles that outlast entire eras of life. Around Mars, its small moon spirals closer over millions of years until it begins to break apart, stretched into fragments that settle into a thin ring around the planet. Farther out, Saturn's rings grow faint across hundreds of millions of years. Their ice and dust slowly lost until only a quieter planet remains. As nearly 1 billion years unfolds, the sun brightens almost imperceptibly, yet enough to alter the balance of Earth. Carbon dioxide fades and plant life weakens, then disappears, as photosynthesis can no longer continue. With that loss, everything begins to unravel. Ecosystems collapse, oxygen declines, and the ozone thins. Complex life disappears from the surface, leaving behind a world that no longer breathes. Over the next 1 billion years, the oceans begin to vanish. Water rises into the atmosphere and escapes into space. Heat builds beyond recovery until the planet crosses a threshold it cannot return from. Another 1 billion years passes and the last traces of life are gone. Earth becomes dry and exposed, shaped only by mineral and wind, a place where biology no longer leaves a mark. As time continues its steady expansion, the moon drifts farther away. Its pull weakens and the tilt of the Earth begins to wander over immense cycles, reshaping climates across a world where nothing remains to feel them. And still, time moves forward. Time continues to expand beyond the scale of any single world. Far from the inner solar system, in the cold distance where sunlight fades, change unfolds with the same quiet persistence. Over hundreds of millions of years, Neptune's moon Triton begins to fall inward. Gravity stretches and weakens the moon across immense spans of time until it finally breaks apart, its fragments spreading into a thin ring that circles the planet in silence. Far beyond, in the darkness between galaxies, two vast structures drift toward one another. Not quickly, but with a certainty that has been written into their motion for billions of years. The Milky Way and Andromeda approach, their shapes slowly distorting as gravity begins to take hold across unimaginable distances. When they finally meet, it is not a collision in the way we understand it. Stars pass each other like distant thoughts, rarely touching, yet everything changes. Their structures dissolve and reform, drawn into a single larger galaxy, a new system where the past configurations no longer exist. In the long aftermath, clouds of gas gather and collapse. New stars ignite out of the remnants, briefly reviving a process that has been fading for ages, as if the universe allows itself one more moment of creation before continuing its slow decline. Closer to what was once home, the sun begins to change after billions of years of stability. Its core shifts and its balance breaks. The outer layers swell outward and its light intensifies as it enters the red giant phase. The inner planets do not survive this transition. Mercury disappears first, Venus follows. The expansion continues outward until Earth is overtaken or stripped down to what can no longer resemble a world, its surface erased beneath overwhelming heat. As more billions of years pass, the sun cannot sustain this state. Its outer layers loosen and drift away, forming a vast glowing shell that expands into space. For a brief moment it shines as a planetary nebula, a final expression visible across the darkness. At the center, what remains collapses into something smaller and denser, a white dwarf. The surrounding gas disperses, the light diminishes. And in the end, only the core remains, cooling slowly in the dark, surrounded by the distant traces of what once was a system. Time continues to stretch far beyond the life of ordinary stars. Across tens of billions of years, the brightest ones are the first to disappear. Their light fades and leaves behind quieter skies, where smaller stars endure. Those closer in scale to the sun follow in time, until what remains are the faintest and most patient of them all, red dwarfs, burning slowly and steadily across spans of time that seem almost without end. As the universe expands, everything begins to drift apart. Over hundreds of billions of years, distant galaxies slip beyond the limits of visibility. Their light no longer reaches across the growing distance. One by one, they vanish from view until only a small region remains, a single gravitationally bound group surrounded by darkness. Within this shrinking island of matter, gravity continues its work. Galaxies draw together and merge, reshaping themselves into larger and more stable forms. Motion gradually settles. Encounters become rare. The universe grows quieter, not through sudden change, but through the slow absence of interaction. At the same time, something more fundamental begins to run out. The gas that once gave birth to stars is steadily used up. Over trillions of years, those vast clouds thin and disperse until no new stars can form. The process that once filled the universe with light comes to an end, leaving only the oldest stars still shining. For an immense stretch of time, red dwarfs remain. They glow faintly, but persist, outlasting everything that came before them. Yet even they cannot continue forever. Across tens and then hundreds of trillions of years, they begin to fail. One after another, they exhaust their fuel and fade into darkness. Eventually, the last star burns out, and with it, the universe changes in a way that cannot be reversed. Light becomes rare. What remains are the remnants, dense and cooling, drifting through an expanding void where distances continue to grow and silence deepens without limit. After the last stars fade, the universe does not end. It continues, but in a form that no longer depends on light, a form shaped only by what remains. Across tens of trillions of years and far beyond, the faintest stars are the last to hold on. Red dwarfs persist longer than anything that came before them, stretching their existence across spans of time that feel almost detached from reality, until even they begin to dim and disappear into silence. What follows is a different kind of universe, no longer filled with stars, but with their remnants. White dwarfs, neutron stars, and black holes. Objects that drift through the dark, carrying the last traces of structures that have already vanished. Every so often, across distances and durations that defy intuition, two of these remnants meet. Dead stars collide and release a sudden flash, a brief and violent return of light that fades almost as quickly as it appears. These moments are so rare that they barely disturb the stillness that surrounds them. Gravity continues its work. Over countless trillions of years, orbits distort and break. Some objects fall inward while others are cast away. Systems that once held together begin to loosen until they finally unravel, scattering their contents into the expanding dark. Planets drift without anchors. Some pass close to the remnants of stars and are captured for a time. Others are torn apart or disappear beyond the reach of anything else. Most continue alone, moving through a universe where nothing remains to illuminate them. Even galaxies cannot hold their shape forever. Over immense stretches of time, encounters between objects slowly scatter what once formed coherent structures. The idea of a galaxy dissolves into a sparse distribution of matter, each object following its own isolated path. There are no new stars, no new structures, no cycles returning. Only the gradual rearrangement of what already exists, stretched across a universe that continues to expand. The universe does not disappear. It endures without renewal. As time stretches beyond anything that can still be imagined, even the remnants of stars begin to lose their permanence. Across spans so vast they escape all intuition, matter itself starts to give way. Not violently and not all at once, but through a slow unraveling written deep within its structure. If protons are not perfectly stable, then time becomes enough. Over durations that cannot be meaningfully measured, they begin to decay. Atoms lose their integrity. The structures that once formed everything gradually dissolve piece by piece until nothing remains that can truly hold a form. What once became stars and planets and galaxies thins into something almost featureless. A sparse presence of elementary particles drifts through space, too scattered to build anything new, too diluted to preserve what once existed. Structure disappears completely. The universe becomes uniform, the same in every direction, empty in a way that leaves nothing to distinguish one region from another. For a long time, black holes remain. They are the last to endure, holding onto their mass while everything else fades around them. Silent and isolated, they persist across stretches of time that outlast every structure that came before, yet even they cannot remain. Through a process so slow it seems almost unreal, unfolding over timescales on the order of 10 to the power of 100 years, they begin to lose energy. Over intervals that defy any scale, each black hole diminishes. Their presence weakens. Their boundaries shrink, until they approach a final moment where the process accelerates. And then, each one ends. A brief release of energy, a final trace of activity in a universe that has already grown almost completely dark. After the last of these moments, there is nothing left that can produce light. Nothing left that can form structure. Energy spreads as evenly as it can. There are no gradients left to drive change, no imbalance left to create motion in any meaningful sense. At the smallest scales, fluctuations continue, but they lead nowhere. The universe reaches a state where change itself becomes impossible, a condition often described as thermal death, where everything that can happen has already happened. And from that point forward, it simply remains, cold, dilute, and without structure. After the last of these moments, there is nothing left that can produce light, nothing left that can form structure. Energy spreads as evenly as it can. There are no gradients left to drive change, no imbalance left to create motion in any meaningful sense. At the smallest scales, fluctuations continue, but they lead nowhere. The universe reaches a state where change itself becomes impossible, a condition often described as thermal death, where everything that can happen has already happened. And from that point forward, it simply remains, cold, dilute, and without structure. At this point, nothing changes anymore. The universe still exists, but it no longer evolves. Time does not stop. It continues to pass moment after moment without interruption. But without change, it loses its direction. There is no longer a meaningful distinction between what comes before and what comes after. Past and future remain defined in principle, yet nothing separates them in practice. What remains is a universe that persists without transition. There is nothing to transform, nothing to rearrange, nothing to build or to erase. The sequence of time extends forward, but it no longer carries any structure, meaning depended on organization. It emerged from systems that could change, from interactions that produced new states, from observers capable of tracing those changes. When structure disappears, that framework disappears with it. There are no observers left to register what remains, no perspective from which the universe can be described in terms of significance or scale. It continues, but it is no longer experienced or no longer interpreted. In that sense, the final state is not an ending, but a permanent state, and from that point onward, it does not begin again.